Assalamu alaikum students. Article for today is a product of vectors, and when we read the product of vectors, we come to know that there are basically two methods through which we can divide the vectors. When we divide the vectors, two vectors are given, like suppose a and b vectors are given to you, and when we multiply those vectors, and as a result we get a scalar quantity, then this product is known as the scalar product or the dot product. Now if after multiplying the two vector quantities, if I'm getting a vector quantity, then this product is known as the cross product or the vector product. So consider we are having two vectors, like vector, suppose vector a is multiplied with a vector b, and as a result we get a third vector as a resultant, and this resultant is basically a scalar quantity, so I'm not going to draw an arrow over this. This is basically the scalar product. Why? Because this quantity which we have received is the scalar quantity, and since we are noticing a dot between the two vectors, that is why it is known as the dot product. Coming towards the cross product, cross product is basically obtained when we multiply two vectors, and as a result I get a vector quantity, right? And since we are getting a vector quantity, that's why this is known as the vector product, and we are having a cross between the two vectors, so that's why it is also known as the cross product. Now discussing the dot product or the scalar product, as I have defined it earlier, if I would really want to know that how those vectors can be drawn, with, like I have mentioned the equation a dot b, and as a result we are getting a scalar quantity, that is c. Then if I want to represent this particular case in vectorial form, like if I want to draw that particular case, so what I have to do? So in this particular case I will definitely write it like this: a dot b, this is equal to a b cos of theta. Now how this comes? Consider you are having a vector, suppose this is a vector, right? Suppose this is a vector b, and we are having another vector which is vector a, right? So if I want to determine that which actually we cannot multiply the vectors physically, right? So two vectors, like I cannot multiply them like this vector is multiplied by that. So for this purpose what we have to do, we have to multiply a vector with the component of the other vector. So for that purpose we need to determine the component of the other vector, or you can say the projection of the other vector which is in direction of the first vector. So consider there are two vectors. I will not definitely multiply both of them physically. I cannot get a mathematical answer like 2 into 4 equals to 8. I cannot get this answer. So for that purpose what would I do? I would definitely like these vectors were originally like this was the vector b and this was the vector a. For multiplication purpose I have drawn the tails of both the vectors, and now I am going to draw the components. So if this is the vector a and this is the vector b, I would definitely love to draw the components of b. Component of b along x-axis, or you can say on a. Component of b on a. So I will draw a projection, and the projection of this vector b on x-axis or on vector a is basically bx, and the projection of this particular vector b in the y-axis direction, it would definitely be by. Now I really want to draw this parallel vector of by in this position, which is now represented as by. Now we see that the vector b's component, that is by, it is having an angle of 90° with a, right? So this is the perpendicular component, and it is in the perpendicular direction. So this is not going to work. We need to determine the projection of first vector, which is in direction with the second vector, or you can say that bx is that particular component of b which is in direction to a. So I can write, if I want to write, I would say a dot b is equal to a multiplied with the projection of b in direction of a, or you can say component of b in the direction of a, right? So that's how we multiply two vectors. There could be another case in which I say that this is the vector a and this is the vector b. If I really want to draw the projection of a on b, then how would I draw that? The projection of a on b would be like this, right? And how I come to know that this is the perpendicular component, so on, because we will definitely draw an angle 90° over here, and theta is definitely in on this point. This is our theta. So when there is a 90° angle and theta, so this is the base, that is the x component. So I'm writing ax, and I'm going to write ay over here, right? So these are the two components of a, and now we see that ay component is making an angle again. It is making an angle of 90°. Ay is making an angle of 90° with b, so this component is not going to work. The component which is in direction of b is basically ax. So if I want to write the equation, I can write a dot b, or you can simply say b dot a, it is equal to b itself and the component of a in the direction of b, which is basically a cos theta, or the projection of a in the direction of b. So that's how we see that the product of a dot b is basically equal to ab cos theta, and the product of b dot a is equal to ba cos theta, which is ultimately becomes ab cos theta. So I can write the condition a dot b is equal to b dot a. This is the main thing which I am going to, this is the main characteristic of dot product, that in this condition commutative law holds, right? So we say that commutative law holds in the case of the dot product, right, or the scalar product. So this is the verification of that. And now coming towards the next characteristic, which is based that what will happen in case of the parallel vectors. Consider we are having two vectors, like this is vector a and there is another vector in the same direction, vector b, right? These two vectors, these are parallel vectors, they are in the same direction. So if I am asked to determine the product of these two parallel vectors, what would be like? I will definitely write in this particular case that a b cos theta. And now coming towards theta. So for this particular case, I see that the value of theta is equal to 0°. So in case of parallel vectors, parallel vectors, what we observe that a dot b is equal to a b cos of 0 degree, and value of cos 0 degree is of course equal to 1, so a dot b is equal to ab. That is the product of the two magnitudes. Now coming towards the fact that what will happen if we are going to take this in terms of the unit vector. Now coming towards the unit vector, what will happen if I'm going to discuss that in terms of unit vector, what will happen in terms of unit vector. Now tell me, we have studied this thing earlier that there are three unit vectors I, j and k unit vector, right? So for this particular case, what is going to happen, we see that the angle between I and j is basically of 90 degree. Here the angle is 90 degree, here the angle is 90 degree, and here as well 90 degree angle. Now what would happen if I want to take the product between I and I, because in the direction of I there is always I, there cannot be j in the direction of I. So to exhibit that thing, I suggest I want to write I dot I want to get the product of this. So what would be the product of this thing? So I will write I dot I equals to, obviously, magnitude of I and the angle between them. Angle is basically 0 degree. Now magnitude of I, since it is a unit vector, so it is having a magnitude equal to 1 and 1, and cos 0 degree it is equal to 1. So that means I dot I is equal to 1. If I dot I is equal to 1, that means same procedure would be adopted for j dot j, which is also equal to 1, and the same procedure for k dot k, we get 1. So that means in terms of unit vectors, what is going to happen, that the product between the unit vectors, if they are same vectors or the parallel vectors, in this case we get the product which is equal to 1. Okay, now the third characteristic, which fourth characteristics, which says what about the case if the two vectors are perpendicular to each other. Consider we are having a and we are having b, and these two vectors are perpendicular to each other. Then what is going to happen? Then obviously I would write a dot b equals to ab cos of theta. And since this is a case of perpendicular method, like the two vectors are perpendicular to each other, so I will definitely put theta equals to 90 degree. It's just the case that b is in this particular direction and a is in this direction, so the angle between them is 90 degree. So if I put the value, it will become a b cos of 90 degree, and this is basically the magnitude of a, right? Magnitude of a and magnitude of b. So it will become a b, and cos 90 degree is equal to 0, so I would write 0 over here, and in this case the answer would be equal to 0. So for a dot b, for the perpendicular vectors, what we get the answer equal to 0. Now in terms of the unit vectors, now if we want to determine this in the terms of unit vectors, I see that I is perpendicular to j and j is perpendicular to k and k is also perpendicular to I. So I would say if I want to determine I dot j, what will happen? The magnitude of I, magnitude of j, and cos of 90 degree, right? Magnitude of I is 1, magnitude of j is 1, and cos 90 degree is equal to 0. So I dot j is equal to 0. If I dot j is equal to 0, That means j dot I is also equal to 0. That means j dot k equals to 0. That means k dot j equals to 0. That also means that we are having I dot k equals to 0 and k dot I equals to 0. So these were the cases in which we have taken the perpendicular vectors and we get the result equal to 0, and when we have taken it in the terms of unit vectors, then we see that for all the perpendicular unit vectors the answer is equal to 0. Now the characteristic number 5, which basically is the anti-parallel vectors. Now for anti-parallel vectors, you must have understood what I'm going to do. Anti-parallel vectors, suppose this is a vector A and this is another vector, vector B. So both of these are completely opposite to each other, making an angle 180 degree. So if I want to take the product of these two, dot product of these two, I would write A B cos of 180 degree, right? That means magnitude of A, magnitude of B, and value of cos 180 degree is -1. So in this case what we observe that we get the value equals to minus AB, right? So that means for anti-parallel case we are going to observe this kind of negative values. Now coming towards the fact that if I want to get the self product, this is going to be the sixth characteristic. If I want to take the self product of the two vectors, like if I've been asked to take the product between A and A, definitely this would be exactly like the parallel vectors. Magnitude of A, magnitude of again A, okay, the magnitude of A, and the angle between obviously A and A would definitely be equal to 0 degrees. So in this case what we observe, A square into 1, so the self product is equal to the square of the magnitude of the two vectors, right? And the last case which I am going to discuss here is in rectangular components, right? Now if I'm going to resolve a vector into its components, like suppose there is a vector given to you that is A with its rectangular components, that is AXI plus AYJ and AZK, right? And we have been asked to multiply this with another, take a dot product with another vector which is BXI plus BYJ plus BZK. Now if I really want to take the dot product of these two vectors, I would definitely write A dot B is equal to, now taking the products, as we have read earlier that the product between the same vectors, that is like I dot I would be equal to 1, j dot j would be equal to 1, and k dot k is equal to 1. But when it comes to I dot j or j dot k or k dot I or k dot j and so on, the vectors are going to be giving the value equal to 0. So if I am multiplying this kind of case, like if I want to multiply these two and these two and these two, right? So only in this case I'm going to get the result, the value of the magnitude. Otherwise if I want to multiply I with the j, then j with the k and so on, I'm not going to get any result. So I would write a x b x into I dot I. The next one, for your convenience, I'm going to write this A x B, Y, I dot J, right? The third one, A, X, AX into BZ into I dot K. For all these cases, what I observed that we are going to get the value only for I dot I, because I dot I equals to J dot J equals to K dot K. This is equal to 1. Otherwise, in any case like I dot J, J dot K and K dot I, so on, all these the perpendicular vectors, they are going to give the resultant equal to 0. So that means this would be equal to 0. This would also be equal to 0. Only this will provide the result. So for the next case, what I'm going to do, I will write like this: AY BY into J dot J and AZ BZ into K dot K. Why I'm writing only these two? Because we would definitely going to get the value for only for these two. Rest of them would give the product equal to 0, so I'm not going to mention those. So ultimately, what is the answer? We are getting AX BX plus AY BY and last AZBC. So this is the product which I'm going to get if I have been asked to calculate the dot product between the two vectors in terms of their rectangular components. Now coming towards the last thing, which is basically the example. So what example? Okay, the example which we are going to discuss would definitely be, you must have read W equals to F dot D. Since in this case force is a vector quantity, displacement is a vector quantity, we are having a dot between them, and work is a scalar quantity. It is not having any kind of direction, right? So this is one of the example of the dot product or the scalar product. There is another example which you are definitely going to read in the next chapters. Chapter 4, this is basically the formula for power formula. You already have read, that is work done per unit time. Now if I really want to somehow change that particular formula, I would write W by T equals to F D divided by T, and this D by T can be converted into F dot V. This is the dot product between the two vectors, right? So this is the case in which when two vectors are multiplied, taking a dot product of them, we are getting a power which is basically the scalar product. So that's how our dot product has been completed. Okay, now we are going to discuss the cross product or the vector product between the two vectors. To discuss the cross product or the vector product between the two vectors, what we are going to do, we would definitely draw a condition in which there would be considering two vectors. Like suppose we are having a vector which is vector A, and we have taken a cross product of this vector with vector B, and as a result what we are going to get A B sine theta with n unit vector. Now what is this n unit vector? We have discussed it previously in the lectures, that n is basically the unit which is used to show the direction of any particular area or the surface area. So how we draw it? By drawing the normal on that surface. So here this n unit vector is going to show the direction of the resultant, which would definitely be perpendicular to the plane in which A and B are lying. Now what I'm saying, I will draw that thing so that you can easily understand that. Consider there is a vector A and there is a vector B, right? So these two vectors are given to you. Now if I want to draw these vectors, what would I do? I would definitely draw it like this. This is vector A, and the vector B like this, right? Now if you're asked to determine the product between, or you can say how can we show the direction of that particular vector, since we get a resultant which is also a vector quantity. So for vector quantity there is a direction and magnitude as well. Magnitude is indicated by this stuff and direction would be indicated by this n unit vector. So how would we determine the direction? For this particular case, we use right hand rule, and this right hand rule says that curl your fingers in the direction from one vector to another vector, right? And then thumb will indicate the direction of the resultant, which is definitely perpendicular to the surface in which A and B are lying. So how would I draw that? Like if I've been asked to take the product between like if I've been asked to take B cross A, right? So what would I do? I would definitely curl my fingers in the direction from starting from point B, from this point, and then I will move towards this point A. So the curl of the fingers would be in this direction of the right hand, and the thumb is definitely out of the screen or out of the page. So thumb will indicate the direction of the resultant by n unit vector. So I am going to draw out of the page like this. This is R, right? And this R vector or any other vector, so it would definitely be having a direction which is perpendicular to the plane in which A and B are lying. Like suppose this A vector is in the direction z axis or the negative z axis, and this vector B is lying in the x axis direction, then definitely our unit vector would be in the y axis direction. That shows that these all are perpendicular to each other. If A and B are perpendicular to each other, that surely means that y-axis is definitely going to be perpendicular to the both of these vectors. So that's why we say that the resultant is always drawn in such a way that it is perpendicular to the plane of the vectors in which the two vectors or two or more vectors are lying. Okay. So for this case, if I want to draw this particular case, so what would I do? Consider there is a vector A and there is another vector B, and if I've been asked to find out this A cross B, what would be the direction of that particular triangle? So for that purpose, what we are going to do is, so in this particular case, what is going to happen that I want to determine A cross B. So for A cross B, I cannot draw the angle like this. This is the angle which we are going to draw in the case B cross A. B cross A means angle would be drawn from B to A. But when it comes to A cross B means that the angle would be drawn from A to B. So I will draw this angle as from A to B, right? So for this particular case, if I want to write the equation, that would be A cross B is equal to AB sine theta and n unit vector. Like now in this case, how would we draw the n unit vector? Now start curling your fingers from this particular point, starting from A, and then move your fingers towards, curl your fingers towards the direction of B. So if I do this thing, my thumb will indicate the condition that it is into the screen or into the page or away from you. So for this particular case, how would I draw that n unit vector, or the resultant which is indicated by the n unit vector, its direction would be like this, right? So in this case, if I say that a is in the direction of negative of z, like this is again negative, and b is drawn in the direction of x, then r would be in the direction of negative of y, right? This is the negative of y. And what we observe, that the direction of this this unit vector and the direction of this unit vector for the resultant r, these are completely opposite to each other. So if I'm going to write the equation, I would definitely write minus n unit vector over here. Why? Because this n unit vector, which was initially in this particular case, it was b cross a equals to b a sine theta n unit vector, right? So for this case, if the direction has been taken as positive, so in this case, the second case, we are going to draw a minus sign with n unit vector, because the direction of both the unit vectors are completely opposite to each other. So that's how we determine the direction of a particular resultant in case of cross product. Okay, so now coming towards the characteristics of a vector product. First characteristic is that we have observed that a cross b is not equal to b cross a. And how we have observed that thing? We have seen that a cross b was equal to ab sine theta n unit vector, and b cross a, it was ab sine theta minus n unit vector. So they cannot be equal, because there is a negative sign in this case, which is indicating that the direction of the both unit vectors are completely opposite to each other. That means resultant are completely opposite to each other. So I can write it like this: a cross b is equal to minus of b cross a. So that's how in this condition we say that commutative law in case of vector product does not hold, right? So this is the first characteristic, which states that the commutative law for multiplication does not hold in case of the vector. Now the second characteristic shows that what would happen if we are going to take the parallel vectors. Now for the case of parallel vectors, what is going to happen? A cross b, and the two vectors are perpendicular to each other. Firstly, to understand that thing, what would happen? Consider there are two vectors. Like suppose there is a vector, this is the vector b, and this is the vector a. In case of vector product, again the same thing, we are going to draw the projection of the other vector. So if I draw the projection of b on a, it on x-axis it would be like bx, and on y-axis it would be like by, right? Now I'm going to draw the parallel vector for by, so this would be definitely equal to by. Now if I observe this particular state, we see that bx is the component which is parallel to a, and by is the component which is perpendicular to a. So in case of vector product, we choose that component of vector for vector product which is perpendicular to the first vector, right? So if I want to write the equation, I would definitely write that in this particular case, a, or generally it happens that a cross b is equal to ab sine theta. That's how you have mentioned ab sine theta with n unit vector, right? So that's how, as the value of by is definitely b sine theta, so that's how we have multiplied vector a with the component which is perpendicular to the vector a, which is b sine theta, right? Now coming back towards the parallel case, I would write a, that is magnitude of a, and the magnitude of b along with sine theta, and the value of theta would definitely be equal to 0 degree since it is the parallel case, and along with n unit vector. So what I'm going to get, that the magnitude of a, magnitude of b definitely, and this would be sine 0 degree, this is equal to 0, and the unit vector n. So what we are getting, we are getting 0, not only 0, but this is a null vector, right? If you are going to write 0 as magnitude, then you have to mention the unit vector as well. If you are not writing it in this way, then you have to draw the null vector. You have to write it in this way. 0 is basically representing the magnitude only. We have to mention the direction, so we are going to mention n unit vector over there, or simply by drawing an arrowhead which shows that this is the vector quantity, not the scalar quantity. Okay, now coming towards the fact. Now if I really want to discuss in the terms of unit vectors, what will happen? If I really want to discuss it in terms of unit vectors, this would definitely be different from the dot product in case of unit vectors. Okay. Now, in case of unit vectors, what is going to happen? If I'm taking the cross product between parallel vectors, like obviously in the direction of I, there is always I, not it cannot be j or k. So the product between I and I unit vector, and this product would definitely be equal to, if I'm going to take I, this is equal to magnitude of I, which is 1, magnitude of I, which is equal to 1, and sine of 0 degree, right? And along with that, we are having the n unit vector, or the vector which is going to describe its direction. So I cross I comes out to be 0 degree. Similarly, j cross j is also equal to 0, and k cross k, this is also equal to 0, right? So for this particular case, what we have observed, that in case of unit vectors or in case of the parallel vectors, what we are going to observe, that we are receiving our null vectors, and that's how we are going to represent the null vectors. Now coming towards the fourth characteristic, and that characteristic is basically the perpendicular vectors, right? So in this case, if I'm going to draw the case for the perpendicular vectors, what is going to happen, like if I am having two vectors a and b, and a b sine theta along with an unit vector. So for this particular case, a b sine of 90 degrees, since both the vectors are perpendicular to each other, and sine 90 degrees equal to 1, so what we get, a b with n unit vector. So that's how we definitely get the maximum value for case of perpendicular vectors. Now if it comes towards the unit vectors, if I really want to draw that thing, I would definitely, we are having I cross j or j cross k or something like that. So for I cross j, it is equal to the magnitude of I, which is equal to 1, magnitude of j, which is equal to 1, and sine of 90 degree. Since in this case, this is I, this is j, and this is k, all are having angle of 90 degree with each other. So answer in this case would come out to be, like here I'm going to write k unit vector, and this k unit vector is definitely going to be the third vector, which is basically the resultant as well. So I'm going to write it like this, sine and 90, which is equal to 1. So overall, what we are getting, k unit vector. So I cross j is equal to k. Similarly, j cross k is equal to I, and k cross I is equal to j. So you must be wondering, how can we easily calculate this thing? How can we easily remember this thing? So for that purpose, just remember this thing. we are having the case in which we are having three vectors, that is I, j, and k. If you want to take the product between I and j, if you take the product between I and j, resultant is definitely like I'm going to take the product between I and j. So according to head to tail rule, if I take I cross j, my fingers would be in this anti-clockwise direction, and thumb will indicate the resultant or the direction of n vector. So that direction is basically indicating the direction of z axis, and z axis, we do represent the direction of z axis with the help of k unit vector. So that means the product between I and j would be equal to k unit vector. Similarly, if I want to take the product between j and k unit vector, so if I draw it like this, j and k, so for j and k, what we are having, use your curl of the fingers from j to k, then thumb will indicate the direction, which is basically I. So in case of j cross k, we are having I unit vector. Now coming towards the fact last thing, that is k cross I. So for if I want to multiply k with I, there would be definitely the third vector. Draw your move your curl of the fingers from k to I, then the thumb will indicate the direction of j. So that's how we have determined all of these characteristics. So do remember this thing, this anti-clockwise direction. Now if you are taking the direction in anti-clockwise case, for anti-clockwise case, we are having all the angles or all the values to be positive. Now if you are going to take the angle in the clockwise direction, so for clockwise direction, like if you want to multiply I cross k, like if you want to do this kind of product, then you get j, but j would be definitely, since it is in the clockwise direction, all the clockwise angles are always taken as negative, so I cross k would be equal to j, but definitely equal to minus j, right? So all the clockwise angles would be taken as negative. So in the case of j cross I, like if I want to say j cross I, this would be equal to minus k. If I want to take k cross j, this is equal to minus I. And if I want to take I cross k, this is equal to minus j, right? So that's how you draw the angles, and you take the values of angles positive or negative accordingly. Parallel and anti-parallel vectors are having the same case as the value of sine 0 degree and sine 180 degree. They both are having the same value, that is equal to 0. So in case of parallel and anti-parallel vectors, what we get as a resultant equals to null vector. So I'm not going to discuss it over here. Now the last factor, that in terms of rectangular component. Now if I'm having a vector, consider we are having a vector A, which is AXI plus AYJ plus AZK, and there's another vector B that is given as BXI plus BYJ plus BZK. So if I want to take the cross product between the two vectors, it would be like A cross B, and this would be equal to the product. In this case, there would be not be the case like dot product, that if I multiply I and I, the answer would in this case would be equal to 0, which was previously maximum. So all the answers, all values will be having the magnitude equals to 0, which are like having the same parallel vectors, like I cross I would be equal to 0, like this would be equal to 0, this would also be equal to 0, and this would also be equal to 0. If I use the same method which I have done in case of parallel vectors, in case of dot product, this is a little bit lengthy method. So I'm going to use the matrices system, and I will solve the two vectors by using the matrix. So for that, I'm going to draw it like this: I, j unit vector, and k unit vector, and the matrix, and the value of now the vectors, that is ax, ay, and az, and bx, by, and bz, right? And you know very well how to solve this particular matrix, and now I'm going to solve this. So this would be equal to I, and it would be equal to ax into by, sorry, it would be like equal to, okay, it would be equal to ay, az into by, and bz. Now the second one, which is a j, so minus j would be equal to, I don't need to discuss that why minus is over here, because we use a plus sign over here, then a minus sign, and then again the plus sign. So that's how we are going to put the signs. Next, for the j, we are having ax, az, and bx and bz. This is the second. And the last one, which is k. For this, what we are having ax, ay, and bx, by. Now, okay, so now we are going to take the using the determinant method, we are going to solve these matrices. And what we get I unit vector a y b z minus a z into b y minus j, एंड माइनस जे के लिए जो मेरे पास वैल्यूज़ होंगी दैट वुड बी ए एक्स बी जी माइनस ए जी इंटू बी एक्स. And last but not least, the k1. Okay, I'm going to solve for k over here. We are having k, and for k we are going to get a x b y minus a y into bx, right? So for after doing the whole procedure like we have done in the dot product, we can use this simple method and more easy and more convenient method to get the resultant. If you really want to change this particular negative sign, so you can do it like this. Ay, we can do it like this, a y into bz minus a z into by I plus j. Taking the negative sign as common, only the value would be replaced. It would be like a z bx minus a x into bz, and along with that k unit vector, which is basically ax into by minus ay into bx. So that's how we take the rectangular components, and we can multiply, or you can say we can take the product of the two, cross product of the two vectors by using the rectangular components. Now if we want, there is the last thing, if we say that the area of parallelogram, the product between the cross product between the two vectors, the value it is having, which it is basically equal to the area of parallelogram. So how can we say that? Consider that you are having two vectors like a vector b and another vector a, right? If you want to take the product that is a cross b, if you are asked to take the product between a and b, it would be like a b sine theta along with n unit vector. Definitely you are going to do this. And now if I say that this case can be developed into a parallelogram case, like if I draw another vector, like this is the parallel vector of b, and if I draw the parallel vector of a in this situation, now this is a parallelogram having an angle theta over here, right? And this parallelogram definitely divides the whole parallelogram. If I want to draw a diagonal in this case, so this diagonal basically divides the two triangles, right? Now if I really want to determine the area of parallelogram, it is having the formula area of parallelogram, it is having the formula 2 into half base into height. What I have done, basically these are the two triangles. Now this is the triangle 1 and this is the triangle 2. And now for these two right angle triangles, what we are going to do, we are going to calculate the value for both the triangles and then we will add them up. So that's why I have mentioned a 2 over here. So 2 into the value would become, now we don't have height in this particular case, so what I'm going to do, I would definitely draw a perpendicular, like in this case this is the perpendicular which I have drawn on A, and the length of this perpendicular is taken as to be h, right? So this is the height, and the base is basically this. So I'm going to multiply base, that is A, along with h. Now if I want to determine the value of this h, I can see that if I draw the components of vector b, so this would be the from here to here, this would be the x component and this would be the y component. If I draw it clearly, this is vector b and this is bx and this would definitely be by. And as you can see that we are having a parallel vector, we can draw a parallel vector of b over here, and we also see that this is also equal to h. So h is basically equal to the y component of the vector b. So I can write it like this, by, or simply you can say b sine theta, right? And after that both the 2's would be cancelled, and what we get a b sine theta. So the magnitude of a cross b is equal to the area of parallelogram. So that's how our lecture ends, and thank you so much for joining us. Allah Hafiz.